Welcome to this YSL DAX for Power BI tutorial. In this part of the series, we're going to talk about using variables. We'll start by explaining why you might want to use variables in the first place, and then explain how you can declare them, assign values to them, and then reference them in other parts of your expressions. We'll talk about how you can nest variables in a specific part of a long expression, and towards the end of the video, explain how you can use variables to hold an entire table. So let's get started. To get started, I've created a new report and I've already imported some data from an Excel workbook. I'll drop a link in the video description so you can download this file yourself. It's just a simplified version of the movies workbook we've used in several videos in this series. So you can see we've imported two tables, one called movies, which is full of data, and then another one called all measures, which is empty apart from a column called delete this column. And we will do that a bit later on once we've added a measure to that table. But for the first example of using variables in DAX expressions, I'd like to start by creating a calculated column in the movies table. We don't technically need to be in the data view to do this, but I think it always helps to be in the data view to see the results of the calculated column. So let's head there first, and then select the movies table, and then create a new column. This column is going to calculate a category for each film based on how much profit the film has made. So we'll subtract the budget from the box office and then call films which have made a loss losers, films which have made a low amount of profit low profitability, medium and high, and so on. So we'll have 3 or 4 different categories in total. Let's call the column profitability, and we're going to use a switch function to calculate the various possibilities. So we'll say equals switch, open some parentheses, and then the expression we'll evaluate is the result of the true function. Using true as the first expression allows you to write logical tests in the value arguments. You'll know this if you watched the previous video on working with the switch function. So for my first value, I'm going to calculate box office minus budget. I'll just hit escape to clear this tooltip so you can see what's going on. So box office minus budget, and then we'll check if the result of that is less than 0. We'll provide a description of loser. Now, each subsequent expression I want to evaluate is going to involve calculating the box office minus budget. Rather than writing that out again myself manually, let's just cheat and copy and paste this. So I'll paste that line in again, and then I'm going to call the next category of films low, as in low profitability, and those will be films which have made less than $500 million of profit. We've got quite high standards here, clearly. So you can either type in a 5 followed by 8 zeros, or if you wanted a shortcut, you can say 5E8. That does the same thing. I'm going to go with 5 followed by 8 zeros. I just need to make sure I've actually added in the correct number there. I have, good. Okay, so then on the next line, let's paste in that expression again. We're going to call the next category of films medium or moderate. And this is going to be films which have made at least $500 million, but less than $1 billion of profit. So that's going to be a 1 followed by 9 zeros. Or again, you can say 1E9 if you prefer. But I'm going to go with the 1 followed by 9 zeros. Finally, for anything else, I want to describe those as high profitability, so let's add the word high, and then we can close the round brackets, press enter, and there's our first basic calculated column created. The main problem with this code is that we've replicated the box office minus budget calculation, and that's inefficient and makes the whole thing awkward to maintain. We can solve this problem using a variable to hold the result of this expression, so we can write the calculation once, store the result, and then reference that result as many times as we like in the same calculated column. To do that, let's provide a bit of extra space above the switch function. And then to declare a variable in DAX, you use the word var, V-A-R. Just ignore the IntelliSense which prompts you with the matching function names. You can press escape to abandon that. Then you'll need to provide your variable with a name. You can use a combination of letters and numbers, and the underscore character if you like, but try to avoid other punctuation characters. So for example, you could call this film profit, using an underscore to separate out those two words. I'd probably be tempted to give this a shorter name. I'll probably just call this one profit. One other thing to avoid is the names of any existing DAX keywords, so don't try to call your variables things like switch or true, for example. Unlike some other languages you may be familiar with, you don't specify a data type for your variables, you just immediately assign a value to it by using an equal sign, and then write out the calculation you want to store the result of. So I'm just going to quickly copy and paste the box office minus budget expression. We can then reference that profit variable in other parts of our calculation. One other thing we must do once we've declared a variable is you must tell your profitability column or your calculated column what value it then subsequently returns. So you notice the red squiggly underline underneath the word switch. To make this valid again, what we now need to do is write the word return. So once you've viewed a variable declaration, every subsequent line in the calculation must begin with a variable declaration or finally the return keyword to get an answer out of that calculation. So what we can now do is replace the box office minus budget expression on all of these lines with a reference to our profit variable. We can do that one by one, or if we wanted to cheat or use a nice little trick, we can click at the beginning of the first movie's box office minus budget expression, hold down the Shift key and the Alt key on the keyboard, and then click at the end of the last expression, and that will highlight that block of code there. We can then simply replace all of that by using the word profit, and you'll hopefully see in the tooltip that pops up in the IntelliSense the little letter X and the name of your variable profit. So you can hit the Tab key to type in the rest of that variable name when you can see it highlighted, and that's the entire expression recreated. It makes no difference to the end result, you'll still see the same answers, but it solves the problems we mentioned earlier on, so I can enter that calculation and still see the same set of answers. You can use multiple variables in the same calculated column. So for example, if you didn't just want to immediately return the result of the switch function, we could capture the result of that part of the expression in a separate variable. Let's change the word return to the word var, and then we'll think of a sensible name for the variable. Let's call this one category, perhaps. And then we can make this one equal to the result of the switch function. Now again, we still need to make sure that the entire expression returns something. If we attempted to enter that formula as it stands, it says that the syntax is incorrect. We haven't returned anything yet. So at the end of the switch function, we can add another couple of blank lines, and then we could say return, and then the name of our new variable, which is called category. And we should see that same little indicator in the IntelliSense. So once we've done that, we can update the expression. We'll still see the exact same end result, but with two variables now rather than just the one. One thing that you can't do with a variable in DAX is change its value once you've assigned something to it. So for example, let's say I wanted to modify the value of the profit variable to divide it by 1,000,000 just to make it easier to write these logical tests in the switch function. In some languages it would be possible to say profit equals and then divide itself by 1,000,000. So in DAX we could say divide, open some round brackets, and then refer to the profit variable again, followed by a comma, and then a 1 followed by 6 zeros, or 1E6 if you prefer. Close the round brackets, and then, as I say, in some languages that will be a perfectly acceptable thing to do. However, in DAX you can hopefully see, with the red squiggly underlines there, that this isn't going to work. You can't modify the value of that variable once it's been assigned. What you could do is declare a second variable which would take a modified version of the first. So we could say maybe var profit mil, and then make that equal to the result of the profit variable divided by 1,000,000, and then we could reference the profit mil variable in the switch function, so we could write things like less than 500 rather than 500 million, for example. I think that's a bit of an over-the-top example, but just to demonstrate that you can't change the value of a variable once you've assigned it in DAX. I'm just going to use the Ctrl-Z keyboard shortcut to undo all that, and then get rid of that extra line that I've created there as well. So back to normal, everything is now working again. Taking this example a little further, I want to deal with the fact that not every film has got both a budget and a box office value filled in. If I quickly scroll down to the bottom of the table, we'll find lots of films with neither a budget nor a box office, and some films with either one or the other value. In any of those cases, I want to describe the film in a special category called no data or missing data or blanks or something like that to indicate that we don't have enough reliable information. We can do this in several different ways, but I'm going to use an if function to change the way my profit variable is calculated. So I'm just going to take down the movie's box office minus movie's budget, a couple of lines, and then after profit equals, I'll use an if function, open up some round brackets, and then check if either of those two values is blank. So I'll use the isBlank function to check if the budget is blank, double vertical bars to say or, is blank, box office. If either of those two conditions are true, I want the profit variable to contain a blank. Otherwise, I want to calculate box office minus budget. Once I've done that, I can add another category to my switch function. So before I even attempt to check whether the film is a loser, I'll say is blank profit, and then a comma, and what should we call this one? Missing data or no data blank? Let's call it missing data. Okay, we can then update the result or the code of our calculated columns definition. And we will hopefully see in the profitability column, if I just click the drop down arrow there, we'll see the extra missing data column has appeared. And if I can scroll down to the bottom of the table where there are missing budgets and box office values, we should see missing data as the category. So that's all working clearly. There's one final change I'd like to make to this example, just to demonstrate that you can nest variable declarations inside functions. This is a little bit over the top for this particular example. It's really just to show you what's possible, not a recommendation that this is the way to do things for this particular calculated column. Let's imagine that in this if function, calculating the box office minus budget was a more complicated calculation that we wanted to break down into multiple different steps. What we could do inside the argument, so the third argument of our if function, we can declare a variable whose scope is limited to this argument of the if function. This is the only place this variable will be available. I'm going to call it PFT, as an abbreviation of the word profit, and make it equal to box office minus budget. What I then might like to do is create another variable still within the same function argument. So I'll go down to the next line. Notice there's no comma here to skip to another argument, so we're still within the third argument of the if function. I'm going to call this one var pft mil and make this one equal to divide pft, comma, and then a 1 million, close the round brackets. And then finally, we also need to return something. So the return is the return value generated for this argument of the if function. So it's not the return value for the entire calculation. I'm going to say return pft mil. Now what that means is that the result that's held in the profit variable has been scaled to 1 million now, so I don't need to change any of the other references to the profit variable, but what I do need to do is change the values that they're evaluating. So I'm going to check for less than 500, but that's, as I say, divided by 1 million in the if function, and then less than 1,000 rather than 1 billion. So we can still hopefully see here the loser, low, low, medium categories in the profitability column. If I update the result of that expression now, we'll see the exact same answers, just calculated in a more complicated way. So, as I say, not a recommendation as good practice, but it is possible you will see variables declared within other functions or nested in other parts of a DAX calculation. So just bear in mind that these variables are limited in their scope to just this argument. I can't reference these elsewhere. If I try to refer to the PFT variable, you'll see that it doesn't pop up in the IntelliSense, and it will be left with a grey font and a red squiggly line underneath it. So there we go. Now let's have a look at using variables in measures. We'll start by creating a measure which doesn't use variables to calculate the profit margin. So let's head to the All Measures table and we'll choose to add a new measure to it. And we'll call this one profit margin. We'll make this one equal to the result of the divide function. And what I want to divide is the result of the total box office minus the total budget divided by the total box office. So we'll use the sum function to calculate the sum of the box office column minus the sum of the budget column, and then we'll divide that by the sum of the box office. We can then close around brackets for the divide function, hit enter to create the measure, and then we'll apply some formatting to that as well. Let's apply the percentage format to that measure. And then once we've created a measure, we can delete the delete this column. So let's right click on that and choose to delete it from the model, confirm that we want to do that, and then we'll get a proper measures table. Just to check that this is working, let's head to the report view, and I'm going to add a basic table visual to the report. We can choose to include any fields we like in there. I'm just going to collapse the filters panel. Let's go with the genre field and then add the profit margin so we can see the result for each different genre. Just so we can see that a little more clearly, I'll head into the format pane and then let's just increase the font size up to about 13, and that should make it a little more readable. So there we go, that's our first measure without using variables. Now there isn't as much duplication here as there was with our calculated column, but there is still some. We've got the sum of box office duplicated. So let's use some variables to avoid that duplication and make the entire thing a little easier to read. Just as we did earlier, we'll provide a bit of space above the divide function, and then we'll declare our first variable by using the var keyword. And let's call this one total budget, and we'll make this one equal to the sum of movies budget. So I'll just copy and paste that. Then the second one will be the total box office. So we'll say var total box office equals the sum of movies box office. And then we'll have a third variable which calculates the total profit. So we'll say var total profit equals total box office minus total budget. Okay, finally we can return the results of the divide function. We'll say return, and then rather than referencing our fields and the sum functions, we can say total profit divided by the total box office. So the end result, when we enter that measure, we won't change the end results, of course. That's kind of the point. We want the same answers. We just want the calculation to be a little more readable, avoid duplication, and make it a little easier to maintain. At the moment, this measure doesn't deal with the fact that not every film has got both a budget and a box office filled in. And dealing with that in a measure is a little more complicated than in the calculated column. To demonstrate how this works, I'm going to take a copy of this measure's definition, basically so we can compare it against the original measure we've created. And I'm going to add a new measure and then paste in all this code and change its name so it's called profit margin no blanks or something along those lines. Now, to calculate the total budget for films which have both a budget and a box office filled in, I'm going to need to use a SUMX function. There are various ways I could do this actually. This isn't necessarily the best approach. I'm doing this in a particular way to demonstrate another feature of variables. So what I'm going to do is I'm going to just provide a bit of extra space here. Then I'm going to use a SUMX function to calculate the sum of the movie's budget. Now you may remember from a previous video that the SUMX function requires a reference to a table as its first argument, if I open the round brackets there. So the table is the first thing you need to define. I want to refer to a table that's the same as the movies table, but excluding any rows which don't have both a budget and a box office. Now there are several ways I could do this in DAX, and you'll see some more techniques used a little later on in this series. For this example video, I'm going to use a function called calculateTable, mainly because its name suggests quite strongly what it actually does. So I'm going to use the calculateTable function. The first argument needs to be a reference to a table, so I'm going to refer to my movies table. And then I can start applying filters to that table. So the first filter, I'm going to make sure that the budget field is not blank. So I'm going to say not is blank, and then in some round brackets refer to the budget field. Then I can type in a comma after that and provide a second filter, and I'll say not is blank, and then I'll refer to the box office field. Okay, so that's the end of the calculate table function. That's the table that I want to calculate the sum of the budget for. So I'll add a comma at the end of that, and then just to get my code laid out the way I prefer, I'll take that close round bracket down to the next line, and there we go. So at that point, that's the total budget calculated, but only budgets where films have got both a budget and a box office value filled in. Now I need to do a similar thing for the calculation of the sum of box office. So what I'm going to do here, in fact, is just copy that entire expression I've just written, the entire sum x, and then replace my sum of movies box office. And then at the end of that, just change the movies budget to refer to the box office field. Then we're calculating the total profit as usual, and then returning the division of total profit by total box office. So if I just update that formula, and then I can add that new measure to my table, and I'll probably want to change the formatting of that as well, so I'm going to use the percentage formatting. And then if I can just clear the formula bar, we'll hopefully see that some of our genres have different results now when we've excluded films where there are blanks in some of those rows. So we're clearly calculating different results for different genres now, and you can see the grand profit margin down at the bottom is different to the original one as well. Once again, a main problem with this measure is that we've duplicated some of its code, and in this case it's the calculate table function that's duplicated. Now we know that this function returns an entire table, but that's okay because in DAX a variable is perfectly happy to accept a table as its value. So what we could do here is declare another variable. Let's call this one something like movies no blanks. I guess movies no blank budgets or box office values would be a more descriptive name, but I think that would be a little bit too long. So let's say movies no blanks, and then copy and paste the calculate table function. Now that we've done that, we can replace the calculate table function in our total budget and total box office variables with a reference to the movies no blanks variable. And I think just because this is a nice, short, simple expression to write now, we can take all this up onto a single line to make things a little easier to see. Let's get rid of the calculate table function there, replace that with movies no blanks, and then finally bring all this back up to a single line, and hopefully that means we can read the entire measure in one single page. One final consideration to make is in how we reference the columns in the movies no blanks variable. Every time we've referenced a column in a table, we precede it with the table name. It's not always necessary, but sometimes it is, and it's good practice to always reference a column name by preceding it with a table. If we try to do that, however, with the variable name we've created, so we say movies no blanks budget and movies no blanks box office, you'll hopefully clearly see from the red squiggly that this isn't going to work. Table variable names aren't allowed as column name qualifiers, so you can only use a reference to a table which exists in your data model, not a table variable. The simplest, easiest solution to this is just to omit the qualifier from the column name entirely and just refer to the column name. So that's the technique we'll go with. If we just update our measures definition now, we'll see the same result is generated just without having to duplicate that calculate table function. So there we go, there's the basics of working with variables in DAX. We'll be using variables throughout the rest of the course from this point on, so hopefully now you've got enough background to understand what's going on. Thanks very much for watching. We'll see you next time.